In this video, we're going to learn how to simplify complex numbers, and we're going to learn about a new type of number called an imaginary number. So throughout your algebra career, you've actually seen that not all quadratics have real solutions. So for example, if we were to graph a quadratic, remember we're finding x-intercepts, you might have a quadratic that looks like this, where it has no x-intercepts, and as a result, it has no real solutions. In addition, in past algebra classes, we've tried to solve equations, let's say, that look like x squared equals a negative 10, and then you try to square root both sides, and if you try to square root that negative 10, your calculator tells you that there's an error and there's no solution. So we've noticed that real solutions do not exist for all quadratic numbers. However, back in history, mathematicians decided that they didn't like that there were these situations with quadratics that resulted in no solution so often. And as a result of that, they created an imaginary unit called I. Now, by definition, I is equal to the square root of negative 1. And essentially what this allows us to do is this allows us to have negative square roots like this one, where we can actually rewrite it as what's called an imaginary number using this value of I. Now, in order to do this, the other thing we'll need to know is that because I equals the square root of negative 1, I squared is equal to negative 1. So notice if I square this and I square this, we get I squared on the left, and these cancel out, so I'm left with negative 1 on the right. So you need to know these two facts right here, that I equals the square root of negative 1, and that I squared itself is equal to negative 1. So what we're going to do here is we're going to use our knowledge of this imaginary I, and the fact that I is equal to the square root of negative 1, and the fact that I squared is equal to negative 1. We're going to use that in order to simplify all of these square roots that we see on the screen. So for each one of these, what I want you to note is that there's a negative number underneath the square root. And as a result, you should already be thinking that we're going to need an imaginary I to simplify this because of that negative value underneath the root. Now, when I simplify these, I typically always start off by rewriting that square root as the square root of negative 1 times the positive version of that number, so in this case, the square root of 25. So I can rewrite that root as the square root of negative 1 times the square root of 25. And then from here, I can simplify each square root. And what I know is that I is equal to the square root of negative 1. So this is an equivalent way of saying I, because the square root of negative 1 is I, and then the square root of 25 is 5. So my final answer here would be written as 5I. So notice that this negative underneath the root is basically guaranteeing that you're going to have an I in your final result. Now if I move on to example 2, if I apply this same thinking, I'm going to start by rewriting this as the square root of negative 1 times the square root of 72. Then from here, I know the square root of negative 1 is I. But then I know that the square root of 72 isn't a perfect square. So then I start thinking through, okay, I have all of my perfect squares. What are the perfect squares that 72 is divisible by? Well, I find out that it's divisible by 9, it's divisible by 4, and it's divisible by 36. And when I look at that, 36 is the biggest number, so I'm going to rewrite this as the square root of 36 times the square root of 2. And then from here, the square root of 36 is 6. So my final answer here is going to be 6I square roots of 2. So again, notice this is pretty much the same thing as simplifying square roots. The only difference here is that the negative underneath the root tells us that there's going to be an imaginary I as a part of that simplification. Then here in example 3, we have a 5 on the outside that stays there, but I'm going to rewrite this root as the square root of negative 1 times the square root of 9. If I then rewrite this, I get 5 times the square root of negative 1 is I. And then if I square root the 9, I get 3. So now I see here I have two numbers. So I have 5 times 3, which is 15. And here we get 15I. So again, Same process as simplifying square roots, it's just it has an I, imaginary I in there now because of that negative underneath the root. And then the last one here, we have -2, and then I'm going to rewrite that root as the -1 times 196. So this becomes -2 times the square root of -1 is I, times, well, I look at 196 and I don't know if it's a perfect square, but I do know that it's divisible by the perfect square of 49. So I get the square root of 49 and then the square root of 4. And what I realize is both of those numbers underneath the roots are perfect squares, which tells me that we're going to have -2 times I times the square root of 49, which is 7, times the square root of 4, which is 2. So what that tells me is that if I had square rooted 196, that's actually a perfect square. I just didn't know it at the time. And then if I multiply the -2, the 7, and the 2, I get -28I. So this process of simplifying square roots that have a negative underneath is exactly the same, except for this time around we're going to have an imaginary I as a part of it that represents the square root of -1. So now that we understand what an imaginary number is, we're going to talk through some details of what are called complex numbers. So by definition, a complex number written in standard form is written as A plus BI. So notice we have the imaginary I. And that's where A and B are any real number that we know. But essentially, the big thing to note here is that a complex number can have a real and or imaginary part to it. So complex numbers, A and B, can be any number, including 0. And complex numbers will have a combination of A, which are real numbers, and B times I, which are imaginary numbers put together. So this is the general form of a complex number. Now, an imaginary number is a complex number where B does not equal 0. So what this means is it's guaranteed to have this B times I part. So the imaginary number has to have the imaginary I in it. Then from here, a pure imaginary number is a complex number where B is not 0 and A does equal 0. So it means that there is no real part. And we'll talk about what some of these might look like on the next slide. So what I want to draw for you quickly here is a graphic organizer of all of the number types that you've learned so far in your math career. So this black box is going to represent all of the complex numbers in existence. So that's all of those numbers that are written in the form of A plus B times I. Now, within the complex numbers, there are two types of numbers that you'll encounter. There are all of the real numbers. And all of these real numbers contain no BI part. Okay? So all of the real numbers contain no BI part. They just contain A. So this means B is equal to 0. So some examples of real numbers would be 3, 4.2, 3 over 4, which is 3/4, 5.3333 repeating. These are all of the numbers that do not contain any sort of imaginary I. So part of the complex number system is made up of the real numbers that we were familiar with and worked with early on in our math careers. Now the other part of the complex number system that we need to be okay with are called the imaginary numbers. And these are the numbers that can be written as A plus BI or BI, but the key is that B does not equal 0. So some of these types of numbers might be 3 plus 4I, or maybe we have -7 minus 2I. Now, within all of these imaginary numbers, we actually have a little subset of imaginary numbers that are more specific, and these are called your pure imaginary numbers. And these are the numbers that do not contain an A value part. So there's no a part. It's just the bi part. So these are going to be numbers like 4 times I, or negative 2I, or negative 5.2I. So you can see that all of these do not contain an a part to that. So complex numbers as a whole are written in this general form of a plus bi. That splits into real and imaginary. The real numbers have no b part, they just have the a part. And then imaginary numbers can have both parts, or it can have just the bi part, and those are called pure imaginary numbers.